One of the other types of loops that we looked at in Chapter 5 is a for loop. So this is a real short little program for a for loop. So I'm going to start a new project for Chapter 5 and call it Chapter 5 Video 4. And be sure that I'm creating an empty project and add my CPP file so I can actually key in the code. Now, what this one is going to do is we're going to prompt the user to enter a positive integer and then use a for loop to calculate and display the factorial of the number. Now, a factorial is the number multiplied 1 times 2 times 3 times 4 to the number. Or if you said the factorial of 5, it would be 5 times 4 times 3 times 2 times 1. Whatever that value is the factorial of the number. So I'm going to start by keying in my plus include statement, and I only need one in this one. This is very short. For loops are very efficient because they are small, and you use them when you know exactly the number of times that you need to run through a loop. So they're very efficient, and we use them a lot when we know the exact number. So IOStream, and I didn't spell that right, IOStream, using namespace std, and my main function starts here with an opening brace. Now, we only have a couple of variables, and they're both integers. One I'm going to call factor, and the other one I'm going to call factorial, because factorial is what we're actually calculating, but factor is the number the user inputs. So I'm going to set factorial equal to 1, because you always multiply the last time by 1. It actually goes in reverse direction mathematically, 5, 4, 3, 2, 1. If I'm doing a factor of 5, a factorial 3 would be 3 times 2 times 1. The user is going to input the factor, so I need to ask them for that. So I'm going to do a prompt statement to enter the number for the factorial. And then, of course, grab it with CN from the input stream, and that's factor. Factor is also going to be the boundary or the limit for our loop. So here is the for statement. For, and you actually can declare the variable that you're going to use to control the loop here. So for in I is equal to 1. I want to start with 1. And I want to be sure that I is less than or equal to the factor. In other words, I don't want to go past whatever number the user entered. Then I'm going to increment I, and that's another nice thing about a for loop, because I have the initial value here, I have the check for the end of the loop here, and I have the increment statement here. All three statements go inside the set of parentheses with semicolons between them to indicate what to do in this loop. This loop only has one statement. So down under my for, I'm going to indent so you can see that it is part of it, and I'm going to say that factorial, and I'm going to do it the shortcut way, times equal I. And then the only other thing I need is the output at the very end telling me what the value of the factorial is. The factorial is equal to, and I stored that value in factorial, so that's what I'm printing, the contents of factorial, and we'll do a couple of line feeds here at the end. Then return 0 to end my main function, and a closing brace. So I starts with 1. Let's say we're going to do a factorial of 3. I starts with 1. 1 is less than 3, so it comes down here and it multiplies 1 times whatever's stored in factorial, which it starts at 1. If I started with 0, I'd get a 0 in there, and that's not what I want. So it's multiplying 1 times 1. It comes back up and it adds 1 to I. So at this point, I is 2. and 2 is still less than or equal to 3, so it comes back down here and it multiplies 2 times what's stored currently in factorial, which is 1. That's 2. 1 times 2 is 2. Then it comes back up and adds 1 more to I in this part of the for statement, making I 3. 3 is still less than or equal to factor, so it drops into the loop and it multiplies there. Remember, there's a 2 in factorial. It's multiplying 2 times 3, which is 6. And then it adds 1 more to I, making it 4. Well, 4 is not less than or equal to factor, so it comes down here and it prints the factorial equals, and what's stored there is a 6. So I'm going to run this program. I'm going to build it first. Let me just go straight to debug. We haven't done it that way. If I start without debugging, it's going to come back and tell me the project has not been built or it's out of date. So you actually can do all of that in one step. And what I'm hoping for is down at the bottom left, build succeeded, and I did get that. So let me move it over. We'll use 3 on this run since I kind of walked through 3. And the factorial 6, just as you saw in the walkthrough. So let me run it one more time. This time we'll get the factorial of 5. And I'm going to put in a 5 here and press the enter key, and it's quick. And 120 is right. That's 5 times 4 times 3 times 2 times 1. So it works, and you can see here how we've done a for loop. And it is, as I said, very efficient.